Okay, so we're going to do inverses of matrices today. And I'm going to show you how to do one by hand. Okay, and then the calculator will do the rest for us. But I just kind of wanted you to at least understand where it's coming from. Right? So you title your notes inverse of matrices. Okay, everybody got that? Okay, so here's what you're going to do. If I give you a matrix, for example, A, and we're going to be A, B, let's do C there, I'm sorry. A, C, B, D. So there's your matrix. It will only have an inverse, okay, which we call it A to the negative 1, okay? It will only work if the determinant doesn't equal 0. Okay, so we cannot have a 0 determinant. Right? Does that make sense? So now I'm going to show you why you even need an inverse. We've talked about this a tiny bit. So this is more of just kind of a reference point. Remember me telling you 1/2 times x equals, let's say, 6? If I wanted to solve for x, I can divide both sides by 1/2. That's one option, right? Well, you can't divide matrices, so you have to come up with another way. So the other way to do this is to multiply by 2/1, correct, on both sides? So x is 12. It's kind of like an inverse of a matrix because you can't divide. So if I gave you something like A times B equals C, if you were trying to solve for B, you would normally divide by A, but you can't. So instead, you're going to multiply by the inverse. So then B would equal the inverse of A times C. Okay, so that's the point or the reason we need an inverse. Okay. But let me show you how to find one by hand. To find an inverse by hand, you have to take 1 over AD minus BC. Okay, I really need both of those to fit on the screen at the same time, so I'm going to slide this down a little bit, just for a second, okay? So let me show you where I got this. Watch. So if this is my original matrix A, if I want to find A to the negative 1, or the inverse, I need 1 over AD minus BC. Show me what that means. This is AD, right, minus BC. So what is this denominator actually? It's a determinant, right? So what you're going to do is you're going to take, to find the inverse, you're going to take 1 over the determinant. Okay, so you're actually doing 1 over the determinant. That's what that really is. Okay, then we're going to go back up here, and then you're going to multiply by this new matrix. And guys, the new matrix is really weird. You look at the original A, right, and you flip these. So you're going to put D here and A here. You see what I just did? I flipped them. And your BC, they stay where they are, but they become the opposite. So then you're going to put negative B, negative C. They keep their original position, but you write the opposite. Okay, so essentially what you have, okay, is this. Now I'm going to come up here and write it one more time. D, negative C, negative B, A. So you're going to multiply 1 over your determinant times. And remember what I did, okay? I switched the order of these two, and then I left these two the same, just changed the sign. Kind of strange, right? So let's give ourselves an example of it. Let's just try, right? So this is what your calculator is doing every single time. So you'll tell your calculator, all right, calculator, here is a matrix. And the matrix it's going to give us is negative 2, 3, 2, negative 4. And the directions for this are find the inverse by hand, right? We're going to do it by hand. We're just going to do 1. Okay, and what were the steps for finding an inverse by hand? To find an inverse by hand, the first step was to multiply your new matrix by 1 over the determinant. So what's the determinant of this? Go this way first, so you get -8 minus what? 6, right? Remember the way you find the determinant, you multiply these two numbers, the determinant equals -8 minus 6, which is what? No, +8 minus 6, I'm sorry. Which is what value? 2. So you're going to take 1/2. And you're going to multiply by this new matrix, this really weird one that you come up with, right? And do you remember what we were supposed to do? We flipped the order of these. We flipped the position. So we're going to put a -4 here and a -2 here. We flipped the A and the D. And then what do you do to the other two? We leave them where they are, but change leave them where they are, no, but change the sign. Make the opposite. They just both happen to be positive. Right? And then now you just multiply everything by 1/2. So let's try it. So A to the -1 then is actually 1/2 of -4 is -2. 1/2 of -3 is -3/2, and so forth. And that is your inverse matrix. So here was your original A, and here's your inverse. It's kind of tedious, right?
To put it in the decimal form or leave it as a fraction?
A fraction if it's possible. Okay, do you see that it is tedious, right? Which thank goodness we have a calculator to do that. Now, here's the interesting fact of that. So the next part of this is something called an identity matrix. An identity matrix is labeled I, and the point of an identity matrix is to actually prove your work. And it kind of, to me, looks like binary code, right? A bunch of zeros and ones. And there's a way to make sure your inverse is what it is. The point of an inverse is for everything to cancel, right? We want 1/2 to cancel, so we multiply by 2 over 1, correct? Well, that's kind of what happens here, okay? You know that if you take your original matrix, okay? You take your original matrix and you multiply it by the inverse. So if you take your inverse and multiply it by the original, you should get this I. What am I meaning by I? It's not a 1, it's actually an I. It's called the what? Why are they using an I? Because it's called the what? The identity matrix. So you know that once I gave you a matrix and you found the inverse, if you multiply the inverse times each other, they get this weird 0, 1, 0, 1 everywhere. Let's just try our answers and see, okay? Our inverse matrix was this weird -2, -3/2, -1, -1. Our A, this was our inverse. Our original was this. And if we multiply those two matrices together, now guys, this is good practice. Can we multiply these by hand? Do you remember how to multiply? It's going to be required on the test. So let's check. Okay, you're going to say -2 times -2 is 4 plus -3. What's 4 plus -3? 1.
Wait,
Okay.
isn't that 2 negative?
Yes, -2 times -2 is +4.
No, I mean the one cover.
No, I'm copying this A. No. So then this is 1. Now go to the next one. -2 times 2 is -4. And -4 plus 4 is 0. Remember, you write your answers across. Correct? Now let's go to the next row. Then multiply the second row by both columns. -3/2 times -2 plus -1 times 2 is 0. And then -3/2 times 3 plus -1 times 4 is 1. So it works. It's called the identity matrix. That's the point of it. When you multiply and A times the inverse in A, you get the identity matrix. Right, so now let's use our calculator to do it instead. Right, I'll show you how. Okay, before I start, what did we say about an inverse? It will only have an inverse, it will only work if the determinant does not equal what? 0. So there's a possibility that there is no inverse. Okay? So let's do number 1 together. So if I gave you 8, -3, -5, and 2, and I'm asking you to find the inverse using your calculator. So what you're going to do is get your calculator out for me, and you're going to enter the matrix in just like we've done before. Right, so you go to the matrix, this is a 2 by 2, so you go over to edit, and you enter the matrix in. Okay, if you're not sure how I did that, remember I went to second matrix, over to edit. I want to edit A, so I hit enter, and it's a 2 by 2, and I enter in the data. Right? Now I'm going to quit out of here, and it will be inverse, which means I'm going to type in my calculator A to the -1, because that's where I typed in my data. So we're going to go back to matrix to get A, so I hit enter. I want the -1, which is right below the math key, and hit enter, and there it is, 2538. And you can actually, if you wanted to make sure it works, you could multiply them together and see if you got the identity matrix. Okay, let's try number 2. Question. Number 2, 4, -1, -8, 2. Use your calculator to find the inverse. Okay, if you did it right, you get this really weird singular match, quit, error. What does that mean? What does that mean, guys? There isn't an inverse. And if you checked really quick, okay, you can look, because 4 times 2 is 8. 8 minus 8 is 0. The determinant here is 0. And you can't have a 0 determinant. So therefore, there is no inverse. Okay, now lastly, you can do it with anything. This time we'll put in a 3 by 3. Move it up so you can see. Negative, that's -0.2, 1.2, 0.4, 0, 1, 0, 0.4, -1.4, and 0.2. See if it has an inverse. Now you're just kind of sharpening your calculator skills to make sure you remember how to do it. Got it? Okay. So let's move to the next type of problem that we're gonna do, right? I'm gonna show you guys how to use a matrix, an inverse matrix, to solve a systems of equations. Because that's really what you use them for, because they're kind of cool, especially when they get harder. Okay, before we start that, I wanna show you, remind you, if I gave you a to the x equals b, okay, how would you solve for x? We kind of already talked about this. Normally you would divide both sides by a, but you can't divide a matrix. So you would multiply both sides by a to the negative 1, right? So x would now equal a to the negative 1, or in other words, the inverse of a times b. That's how you would solve it, right? So on the same token, okay, if I give you this, if I tell you that you take each one, so 7, I'm going to give you an equation, 7x plus 5y equals 3, and 3x minus 2y equals 22. Okay, and we're gonna actually work on a matrix equation. Okay, and there's 3 parts to setting it up, and then, so the first part of it is you're gonna use the coefficient matrix. It's called the coefficient matrix. And it's made up of all the coefficients, 7, 3, 5, negative 2. Okay, and we would kind of classify that as the A. Okay, then the next piece of it is your variable matrix. And what 2 variables do we have, guys? X and Y. And it equals something called the constants, or your answers, 3 and 22. Your constants. Now in another color or something to help you remember, you might write down, this is called your matrix equation. Guys, on like tests and quizzes, I'll actually ask you to write the matrix equation. That's part of it. So if that's the case, this is your first matrix, A, okay? This is your X, what you're looking for, right? And this is your B, your third matrix, agree? So I need X and Y, don't I? So if I want to solve for X and Y, I need to get rid of this matrix. So to get rid of the matrix, normally if I was looking for X, I'd divide both sides by A. We can't do that. So we're just going to multiply by the inverse. So that means X would equal A to the negative 1 times B. That's important. If you want to find your variable matrix, you do A to the negative 1 times B. So your calculator, of course, will do all that. So
Will it ever ask us to find like a different thing, like the constant or something? Like, will it
No.
give us the variable matrix?
the constants you have. Yeah. Okay, so go in your calculator, guys, and let's enter in A and B. Now, matrix B is a 2 by 1. And then quit out of it. So enter in matrix A and B. And to solve in your calculator, you actually go to matrix A and you type in the inverse times matrix B. That's what you're looking for, right? And it gives you 4, negative 5. Okay. that means if I give you 4, -5, and that was the x, which is this, okay, the answer to a systems is an ordered pair, so that meant the answer was 4, -5. That is the point they intersect at. That's the only point that makes both equations true. Alright, so here's your next problem. This is a little different. This is a 3x3 matrix, right? Okay, but the idea behind it is exactly the same. You will be asked, again, like I said, to set up something called a matrix equation. Okay, so let's set the matrix equation up for this systems of equations. Okay, so the matrix equation would be 1, 1, and 3, because remember your coefficient matrix goes first. 3, -1, -4. I'm going to watch very closely to make sure they're x, y's, and z's. 2, 3, and 2. Okay, that's the same thing as A. Then you multiply it by your variable matrix, which is the same thing as x. And the 3 variables this time are x, y, and z. And it equals your constants, which are 9, 16, and 28. Or we're going to call that matrix B. If we could, we would say, okay, A times X equals B. So to solve for this, we divide by A. We can't do that. So then that's the same thing as X equals A to the -1 times B. So that's what we're going to do. We're going to type in A and B. And to get this matrix, we just do A to the -1 times B. Okay, I'll give you a second to do that. You should get 6, -1, 3 for your answer matrix if you do it right. 6, -1, 3 in your answer matrix if you do that accurately. Guys, as you know that more problems come from systems, so we're going to set up the systems of equations and we're going to use inverse matrices to solve. Okay, so let's read the first word problem. There are 27 centipedes and millipedes in the field. Each centipede has 175 pairs of legs, and each millipede has 336 pairs of legs. There are 14,924 legs in the field. How many centipedes are there in the field? Okay, guys, when you're trying to do this, if I'm solving, I'm asking how many centipedes. Well, obviously there are centipedes and millipedes in the field, right? So I want to know how many of each are in the field. So how many variables is that? 2. So how many sets of data do I need then? I need 2 lines, 2 pieces of information. Okay? So let's look at the first thing. I know that there are 27 centipedes and millipedes in the field. So altogether there's 27. How could I represent that? Good. X plus y equals 27. Or since we're using centipedes and millipedes, let's go with C and M. Okay, so I know that my centipedes plus my millipedes together in the field, there are 27. And what I like to tell them when we solve these kind of word problems is money goes with money, right? Well, in this case, it's not money. What are we dealing with now?
Legs.
Legs. The legs go with legs, right? All the information about legs need to go together. So I know that each centipede has 175 pairs of legs. They're kind of trying to trick you there. Okay? But there are 14,000 legs total. So you either need to put them all in pairs or put them all in legs. So let's just change this to double. So this will be 350. And change this to double, this will be 672. So I'll give you a second to try to write the next sentence, number sentence. What do you think? So 350C plus 672M equals your 14,000. Now you've got a systems of equations, 2 by 2, correct? So remember on the test and quiz, you're going to be asked to set up a matrix equation. So let's set up a matrix equation. Your coefficient equation first, or your coefficient matrix first, times your variable matrix, in this case it's centipedes and millipedes, equals your constants. Okay, and we know that matrix A times matrix X is matrix B. We're calling it X because there's nothing in it, it's the variables. So to solve for X, we're gonna multiply the inverse of A times B. When you type it in your calculator, it only is asking for centipedes. So when you get your answer column, you only need the top answer, which should give you 10. Right, so this is the next one we're gonna solve. Remember, you need to just dig out the data that you can, okay? The first thing it says is that the sum of the three numbers is 24, right? It doesn't matter what you call the three numbers, guys, okay? So, but that is a big chunk of information. I know that all the numbers added together gives me 24. Okay, that's plenty of information. Let's go to the next part. It says the largest number is 3 times the smallest. I don't know what the largest number is, and I really don't care, okay? It doesn't matter what you assume is the largest. Because I put them in order, I'm gonna say small, medium, large. It doesn't make any difference, right? So I'm gonna say small, medium, and large. So the largest number, which in my case would be Z, whatever you pick, is, what does the word is mean? So I'm saying the largest number, Z, is equal 3 times the smallest. Which one can we represent as the smallest? Yeah, the first one, or whatever you pick. Okay, so Z equals 3x. Now, some of you may be saying, wait a minute, that doesn't give me any information about y. Yes, it does. The coefficient of y in that equation is 0. That's okay, right? So now let's go to the last piece of data. It says the middle number, okay, which we're gonna call what? Y. And there's that tricky word again, is, which is what? Equals 4 less than the largest. How would I represent 4 less than the largest?
3x minus 4.
Z minus 4. Okay, so y equals Z minus 4. Now then, knowing that, okay, I'm going to clean it up. So, because I've got to put it in a coefficient, a matrix equation. So in this particular one, 3x is going to go in front. I don't have a y, so I'm going to call it 0y plus z. It should be negative 3x because I moved it over, I'm sorry. Negative 3x plus 0y plus z equals, what does that leave on the right side if I move everything to the left? 0, which is fine. Go to the next one. I don't have an x at all, so 0x. Okay, plus y. I have to move the z to the other side, so minus z equals negative 4. Right? And then you're going to be asked for a matrix equation so you can solve it. So your matrix equation then would look like 1, negative 3, 0, 1, 0, 1, 1, 1, negative 1. Okay, that's your coefficient matrix. Your variable matrix has 3 in it, x, y, and z. Your constant matrix would be 24, 0, and negative 4. Okay? When you plug it in, remember your formula is A times X equals B. So to get your answer matrix, you need A to the negative 1 times B. When you do that, your numbers are 4, 8, and 12. X, Y, and Z. Okay? Now you can work on your own. I would personally do the word problems first, because I think that's where you struggle.